Our next speaker is Marty Candace from SDSC, who somehow on his way from San Diego to Madison, like a long stop over in Ames, Iowa. So he's going to tell us all about that.
Yeah, I've actually been. So, yeah, thank you for having me here at Condor or HTC. I've been to one Condor week in the past, about 9 years ago, I think. So it's been a while, but I still dabble in Condor a bit. And so this is, I work in the HPC group at SDSC, so this isn't really my day job, but this is kind of one of those fun projects you get involved with because the management slices and dices your time into other grants to do things for people. And so this is kind of one of the fun side projects that I've been working on, and where I think I found a use for us to sort of use Condor as part of this project. So let me try to explain to you what we're doing here. Oh, going. Okay, great. So ARA, so I want to tell you what ARA is, and then I want to tell you about these sort of distributed inference experiments that we're going to try to run on ARA. And the reason we're doing these distributed inference experiments essentially is I work for one of these AI institutes funded by the NSF, and there's a lot of sort of computer vision tasks we're thinking about in sort of the agriculture space. And so combining the resources at ARA with sort of running these AI workloads in the field, in combination with resources back in the data center and things is kind of what we're trying to explore here. And while I was thinking about doing a demo, I did seriously get some screenshots of a demo that I ran myself this morning. So hopefully I'll get to show you a little bit about kind of what the ARA interface looks like and why sort of Condor is in the mix here. But so what is ARA? So ARA is a pretty big project funded by the NSF as well, in this Platforms for Advanced Wireless Research project. There's sort of 4 different test beds that are exploring wireless technologies in different contexts. And so ARA is focused on sort of the rural broadband challenges and different applications that you can use it for. And so this is why my collaborators are out in Iowa. So they have a lot of agricultural and rural communities that they're trying to connect with their platform and explore the different applications and technologies and what's possible. So this is kind of the vision for ARA. Again, not only to necessarily connect sort of the agricultural applications, but also the community applications from hospitals and schools. In terms of the research that we're doing, it's more focused on sort of the understanding the agricultural space. And so they have part of the test beds deployed at sort of the ISU agricultural research farm. They have like connected robots and drones and things to it. And so this is kind of what we're interested in. This is a little bit more detailed picture when you start putting in sort of the networking details of what's going to happen in ARA. And there's really 3 major components of the system itself. The first one is ARA Hall. So this is sort of the long-range backhaul between the different sites that are connected in this sort of mesh network, point-to-point communication backhaul network that connects all the different ARA RAN sites to the data center back at ISU. So the second major component is the ARA RAN sites. And so there's a mix of radio access network technology. So kind of your cell towers, essentially, you can think about at different sites around Ames that are then, linked back to the whole system through that ARA backhaul, right? And so this is sort of how the different technologies start combining. And then to manage the system, they use an OpenStack-based platform, loosely sort of cobbled together from like an early version of sort of the Chameleon testbed OpenStack deployment. And so that's what they're using. I would say it's unfortunately a little bit more primitive, and I'll show you why. And this is one of the reasons why Condor is sort of inserted here to help manage moving around some of the workflows on the system. But that's sort of the cartoon picture. So in reality, this is sort of what it looks like right now. So this is kind of their latest Google map, which is actually updated a few days ago, I think. And they're in their sort of phase 2 deployment. So it's been around for a couple years now where they've had sort of users on the system. Really went public, I think, in 2023. So it's almost 2 years sort of open test bed for anybody who wants to sort of get an account on the system and use it. So yeah, you can see here. So these are the ARA Hall links between the different base station ARA RAN sites. All the other little dots around there have the ARA RAN sort of client side infrastructure to connect to those base stations. You can kind of see there's a mix of different types of what they call in this space user equipment. UEs is kind of the terminology for, be your cell phone or a connected bus or something like that, right? So all the equipment on the other side is called the UE, and that's what those other dots are showing, basically. Just some numbers on the ARA Hall platform. This is like what it looks like in terms of the first link that was in phase 1. So they have a dorm here with their rigs on top of the dorm that then, say, connect to this essentially cell tower out at the agronomy farm about 6.5 kilometers away. And these are sort of the main 2/3, these first two boxes, links that they have. So they have sort of a commercial millimeter wave, microwave dual band sort of connection that, depending on which link you want to use or sort of, duplex, will determine the capacity of the link that you have between the two sites. They also have an experimental, like all optical, free space optical system that they're built in-house that they're testing. It's sort of operational, not really open for public use yet, but that's sort of pretty interesting. So those are the 2 or 3 main links between, say, these ARA Hall sites, or at least this one that was in phase 1. And they also have a new satellite terminal to this OneWeb global backhaul system as well. On the ARA RAN platforms, they again have multiple different sets of technologies. They have 2 commercial off-the-shelf systems. This sort of Ericsson, two radios of Ericsson, and one of this Skylark is sort of more of a startup, operating in obviously different bands, so they can explore the different frequency bands for the different technologies and the different capacities that you might get, and obviously the ranges of the different systems. I knew I was going to forget to update some of the slides, so I was furiously finishing things this morning. I haven't finished filling out all the things. But then, again, in the RAN system, there's always sort of 2 sides of the system. There's the base stations, which are sort of the big radio equipment, and then the things deployed out in the field. So this is sort of what they call their fixed UEs, user equipment. So they have multiple client-side user equipment radios installed here with a computer and things like that, which is what we're going to use, because there's a computer attached to all these things. And so that's where Condor is going to run. Of course, there's a bunch of other infrastructure, just regular compute nodes, PDUs, cellular routers for the management networks for all these remote systems that you need to sort of have OpenStack manage, and then obviously switches. But as part of the experiments, right, if we're doing all those sort of wireless networking and testing sort of latencies and bandwidths over the air, weather is going to be important as well. And so they have pretty nice weather stations and sensors that you can sort of ping through an API to collect real-time weather data as well while you're running your experiments on the system. And this is kind of what is the best diagram that I've found so far from the project of explaining how all this is connected. I'm not going to go into any of these details here, but this is, if you want to sort of look at it, I mean, there's a management backplane, there's an experiment plane where sort of the users live, but this is sort of the most complete picture that I've sort of found and helped me untangle what's actually happening here. Okay, so that's ARA. And this is sort of the conceptual idea of the experiment, right? So we have the user equipment out in the field. You can imagine their tractors or drones flying around maybe. These are just going to be the fixed UE, at least to start experimenting here. You have the base stations. At the agronomy farm base station, there's even like a regular sort of data center node with a GPU in it. So it's sort of a GPU a few hundred yards away, maybe a kilometer away from some of these that you can maybe try to connect to and offload some of the inference, maybe be done by the equipment in the field to the local farm, or even maybe backhaul it all the way to the data center, or beyond, maybe even if we want to go that far and see how far we can push this by backing these sort of smaller compute resources in the field with the advanced wireless networking. How far can you push sort of the throughput and characteristics you want to get out of a distributed sort of inference system. So that's sort of the main idea and when we're looking at computer vision tasks here. So the design of the experiment is sort of to stick to these ML-perf inference benchmarks. If you're not familiar with ML-perf benchmarks, there's sort of a consortium now under the ML Commons consortium that maintain the benchmarks that are designed for AI ML sort of hardware testing and software testing, essentially, right? So you want to be able to design some fair benchmarks to understand the different hardware you might buy. Obviously, some people in this room might know. You need to understand sort of the performance characteristics you expect to get out for the different types of applications you might run on your systems. And for the inference benchmarks, like all of the benchmarks, there's always sort of a AI ML task that you define. There's a model that's specified that you have to use, a data set you're supposed to use, and sort of the quality or target metrics you're supposed to hit in order to sort of get a passing grade. On the inference side, it's a little interesting though. They actually specify also sort of the workload scenarios that you have to run. And so you can imagine there's different ways you might be doing inference for different applications, right? And sort of in that, sort of cartoon of the distributed inference experiments, like we're really in this sort of multi-stream case where you might have multiple devices in the field taking pictures, sending video or something back over the system. And, the distributed inference system will need to respond, right? That's sort of the different types of scenarios. These are just the 4 scenarios that are specified here. But that's sort of the most complicated one. This is how the specification of the benchmarks looks in sort of diagram form. There's a load generator that generates those workload scenarios that talks to something that you have to define and how implement this query sample library, which sort of just reads in the data set, tells the load generator, these are the samples that are in this experiment, in this test. And then the system under test is really the model, the framework that's running the model, and the hardware that's going to run on, right? And so that's sort of the 3 basic components of this sort of standard closed division. If you look really close at the specifications, though, they do have a little explored network division where you move the system under test that you want to evaluate off of where the load is being generated. So you can imagine this is your camera with a wireless connection sending those images to be inferenced over the wire to the system under test where your inference compute workload would actually run, and then send the results back to the system that needs it. And so this is, in the spec, but you have to implement this, query dispatch library, which is essentially like a proxy or load balancer that would send out those requests to the remote system under test. But luckily, they also say, well, if you want to break the rules, there's an open division, and you can do kind of whatever you want, but this still provides a nice framework for understanding how to set up these types of experiments, right? So, in this previous picture, right, we still have maybe compute that we can use here on the device. So why aren't we going to use it? So in sort of this way we're going to design these experiments is to load also the local resources, but also offload some of the inference to these remote resources over the wireless, right? That's kind of the idea. And understanding in this sort of framework, how good can we do relative to those standard metrics in the ML-perf is kind of the idea. Okay, so how does Condor come So this is zoomed in on that original sort of diagram that shows sort of what we're trying to aim for here. And so the idea is to put Condor submit and execute nodes on, say, these UE devices, the devices in the field that would actually be, generating the inference workload that needs to get sent off or run locally, and some of it sent off. And so there's also, we're going to deploy Personar, which is sort of to measure real-time network metrics as well during the experiments, or sort of in between the inference experiments, so you sort of understand the current state of the network as well. As you see here, though, the reason we're using Condor somewhat is everything, again, runs on OpenStack, and I don't know if anyone's ever used the Zune container environment. So that's the OpenStack container environment, the Dolphin here. And so having a bit familiar way to distribute computational workloads is the kind of game that I'm using Condor here for. So again, every sort of compute element that we want to target for inference will have sort of a submit and execute node. It's kind of the design. Put a central manager somewhere. The nice thing about this is, ARA is a bit complicated because it always gives you new management IPs all the time. And so as long as I know the one where the central manager is, I can just point all of the execute nodes and, submit nodes to that one to sort of, worry about looking up all those IPs and doing things manually is essentially how you have to do it now. And so that's the idea, and how Condor comes into the picture. And so this is sort of just a quick list. I probably can put more on here, but these are sort of some of the key things I thought of this morning while I was finishing the slides. Again, I just mentioned, having one IP to target everything at, to sort of bring these resources together into a manageable pool of things that you can run things on is great, and not have to worry about each device being slightly different with different CPUs and memory, and it just works, right? The Python bindings will be inserted into the query dispatch library, right? And we're sort of thinking about two different modes where you can sort of do a traditional sort of batch mode where you just run the inference like batch jobs as you send, packets back over, through the HTCondor sort of file transfer mechanism. But also, right, I didn't quite explain that, there's sort of a different mode where we'll actually spin up sort of API servers for inference. And so Condor will launch those inference server jobs, this fast API server jobs, sort of as a way to sort of orchestrate that before we start sending the requests. Another part is ARA has lots of different network interfaces on many different devices. And so having the multi-home sort of support is going to be key. And if we want to go beyond ARA is very private and very locked down. And so to get resources from outside of ARA into this system, which is kind of also what we're considering, doing the sort of Condor connection broker stuff is going to be key. And so I think I'm out of time. I think so, yeah. So I will stop there and leave the demo for you to look at. It just runs an iPerf as Condor jobs between these two elements at the end. And I will just thank NSF and the people at Icicle, the funders of ARA, and take questions. Yeah.
Thank you, and it's at some level a dream come true, that because for many years I believe that Condor can be an effective tool in network measurement. And one, I would really like, to the extent that you're willing to keep me informed in what you are doing, and think about ways to do more, to do better, because over the years we added some features into Condor to, for example, synchronize the activities across the execution point. For example, you can tell that start running these whatever software provided by the application at this time at the node.
Yeah, that's
So
yeah, that's something that, you know, I've only started really digging back into the documentation last year or so, but yeah, that's something that would be interesting because, right, you know, what I showed in the sort of, you know, diagram of software stack, right, with Personar as sort of like a way you can schedule, right, the network measurements, but in between there, I want to schedule the inference jobs, right? So
yeah.
so I want to design a schedule like that. Yeah.
So that is, and with our beautiful, amazing documentation, it may take you another 40 years to figure out all this stuff.
Yeah.
So talking about it, I will be able to. The other thing, since you have Condor running on these, I would encourage you to think about Condor also as a way to monitor the state of your infrastructure, because each of the Condor components can send you back to the collector quite a bit of information, and you can customize this information with what we call Hawkeye. So you can write your own probes that will go into the class ed that the Condor software is sending to the collector, and that becomes available to you. So you can create a dashboard that Todd is willing to tell you more than you want to know about how to take all this and to summarize it. And this can be fully customized. So keep in mind that Condor can manage tens of thousands of nodes that you have there and has to keep track of them and know what the heck is going on.
Yeah.
And you can leverage all this stuff
Yeah.
to keep track of your network. So pull me in as much as you want into it, because it's really something that I believe that Condor can provide, which is beyond uh, running jobs that figure out whether it's a cat or a dog.
Yeah, no, I think, yeah, that'd be helpful. Yeah, like again, right now it's what I didn't mention in the demo, right? That interface that you see on the web page, that's all you have. That is the API. You have to point and click in their Horizon OpenStack portal right now. So having Condor and all the functionality, like to actually programmatically access and move things around and do stuff, is exactly why we're using it. So, yep.
My presentation is happening.
Great.
Okay, thank you, Marty. Give a big